Hello and welcome to this YouTube channel. In this video, I want to answer this question under the topic chemical equilibrium. The question reads, a mixture of 0.1 mole of NO, 0.05 mole of hydrogen, and 0.1 mole of water is placed in a 1 liter vessel at 300 K, that is the temperature. So we have been given the equilibrium equation, which is this one here, the equilibrium equation. Then they give us that at equilibrium, the concentration of NO is 0.062 m. So the first question is asking us to calculate the equilibrium concentrations of hydrogen, nitrogen, and H2O. Then thereafter, the second question is asking us to calculate the Kc, which is the equilibrium constant. So how do you answer the two questions? Before we can even look at how you can answer this question, if you have not subscribed, please do not forget to subscribe to this YouTube channel and follow us on the Facebook page. So the best way to answer this question is by coming up with a table that illustrates the information that we are discussing. So I'll develop this table that will illustrate that the information that we are discussing, and then it will help us to answer the question correctly. So in this table, I'll put the reactants and the product. So we have this one, then we have this one, then we have the arrows that are showing that these two are the reactants, then the other side we have the product and 2H2O. So this is the table that will help us to answer this question correctly. Now, after establishing this table, you need to understand the question and come up with the initial concentrations from the question. So let's have the initial concentrations. What are the initial concentrations of each reactant and each product? According to the question, for NO, the initial concentration is 0.1. Now, why are we saying 0.1 is the initial concentration? It's because the vessel which we have is a 1 liter vessel. So this simply means the number of mole divided by 1 gives us the concentration, which is 0.1. So if the volume of the vessel was 2 or any other number, we would have first divided the number of moles with the volume to get the concentration. In this case, the concentration for NO is 0.1. Then the concentration of hydrogen will be 0.05. The concentration of N2 has not been given. So this simply means when the reaction was starting, the concentration of N2 was 0. The concentration of H2O, we have been given, it is 0.1. So after identifying the initial concentrations, we now want to look at what will be the change as this reaction achieves equilibrium. Now, the change of this reaction is in terms of x. So, for NO, because it has the coefficient of 2, we are simply saying 2x should be the change in terms of the reaction or the reactant NO. For hydrogen, because it has 2 also, we are saying it will be 2x. For nitrogen, initially there was no nitrogen, and the coefficient here is 1, so we are simply saying for nitrogen the change will be x. Then for H2O, because we have 2 there, the change will be 2x. Now, for nitrogen and H2O, this change should be a positive change, while for the reactants, this change should be a negative change. This simply means at equilibrium, the expressions will be illustrated as the concentration at equilibrium for NO should be 0.1 minus 2x. Then for hydrogen, it should be 0.05 minus 2x. Then for nitrogen, it should be x. And then for H2O, it should be 0.1 plus 2x. So these are the equilibrium expressions that are expected in terms of the change and when this reaction reaches equilibrium. Now, what will be the final values? What will be the final values? These final values answers our question A. The final values answers our question A. Now, for NO, we have been given the final value, which is 0.062. So this is the final value for NO. We can use the final value of NO to find the final concentration of these three, which answers our first question. How do we use this? We are going to use the final value and the equilibrium expression to find the value of x. So what do we mean? We are saying 0.1 minus 2x should give us 0.062. This expression which we have here should give us the final concentration. So we have equated the expression with the final concentration. At this point, we can manage to find the value of x. So how do we manage to find the value of x? We are simply saying it will be 0.1 minus 0.062 is equal to 2x. So 0.1 minus 0.062, it is giving us 0.038 is equal to 2x. At this time, we divide both sides with 2. Then x is equal to the answer that we have divided by 2. It is giving us 0.019. So this is the value of x. So where there is x at equilibrium, we can replace it with 0.019. If we replace at the equilibrium stage 0.019 where there is x, then we are able to get the values of these three equilibrium concentrations which we have been asked. So let's start with the first one. The first one we have been given is 0.05 minus, then we are saying 2 multiplied by 0.019. What is the answer? It is giving us 0.012. Then you go to the next one. Here for nitrogen, they are saying the equilibrium concentration is equal to x. So it is simply equal to 0.019. Then for the last one, the equilibrium concentration is equal to 0.1 plus 2 multiplied by 0.019. It gives us 0.138. So these are the three equilibrium concentrations of hydrogen, nitrogen, and H2O. Reached this far, you can see that we have managed to calculate the concentrations of hydrogen, nitrogen, and H2O. Please do not forget to subscribe to our YouTube channel and follow us on our Facebook page. Let us look at now the B question, which is asking us to calculate the Kc. Now, for us to calculate Kc, we need to have these values which we have tabulated here. That is the concentrations of each and every reactant and product in the equation. After having these, we need now to make the equilibrium expression, remembering that the equilibrium expression starts with the products dividing it with the reactant. So the equilibrium expression is equal to the concentration of nitrogen multiplied by the concentration of water. In the balanced equation, the coefficient of water is 2, so this will be to the power 2. Then divide by the reactants. Now we have NO. The coefficient is 2, so it will be to the power 2. Then we also have hydrogen there with the coefficient of 2 because it's to the power 2. After we have written this equilibrium expression, it's now time for us to put the values that we have found here in the expression. So we'll say Kc is equal to the concentration of nitrogen is this one, which is 0.019 multiplied by the concentration of water, which is this one, which is 0.138. This should be squared. And then we are dividing it with the concentration of NO. The concentration of NO is this one, which is 0.062 squared, and the concentration of hydrogen, which is 0.012 squared. Now you have seen I was ticking what I've used so that I do not make any mistake when I'm putting these values in the expression there. So let's do the calculations. What is on the numerator? We are saying the numerator is 0.019 multiplied by 0.138 squared. What is the answer? It is giving us 3.6 times 10 to the power negative 4. Dividing what is on the denominator. So what is on the denominator is 0.062 squared. Then multiplying it with 0.012 squared. What is the answer? It is giving me 5.5 times 10 to the power negative 7. So Kc is equal to dividing these two values. So the values that we have is 3.6 times 10 to the power negative 4 divided by 5.5 times 10 to the power negative 7. What is the answer? The Kc is equal to 654.5. So this is the value of Kc. might notice that this value is too big. This simply means this reaction favored the product. So hope you have followed how we have done the steps to calculate this question. Do not forget to subscribe to our YouTube channel and follow us on our Facebook page for this and more videos.